All right, this video is to complete the rest of the systems of equations. This is going to be the modeling of systems of equations. So modeling systems of equations means we're going to do some word problems, the things you guys love to hate. So anyways, a solution of a real-world problem sometimes requires us to create two or more equations whose simultaneously solution is a solution to the problem. So, for example, an investor has $200,000 to invest, part at 8% and the remainder at 3%. If her investment goal is to have an annual income of $13,600, how much should she put in an investment? So the thing is we want to set this up and model it as two equations. So the very first one that I've come to think about is I'm going to do part of 8% and another part at 3%, but I'm going to have the annual interest goal of 13,600. So that means I'm going to label X as part A and B, or this 3%, as Y. So I'm going to say 0.08X plus 0.03Y equals to 13,600. Now, again, we don't really deal with percentages, so the best way to change 3% into a decimal is to move it two decimal places over to your left. Okay, so we have 0.08, 0.03y, and that equals to 13,000. But overall, when she adds up both of these, right, both parts of her investments, but we don't know how much she has invested, it will add up to be 200,000. Okay, now since we've been learning about systems of equations, that means that we will need to either solve it by substitution, elimination, or we can graph it. So technically in this case, we are going to keep it really simple and we will solve it by substitution. So that means I'm just going to take one of these variables and solve for x. So I am going to take this and say x plus y equals to 2,000 or 200,000, I'm sorry, and solve for x. So that means I'm going to subtract the y from both sides, and x equals to negative y plus 200,000. Okay? Now, in substitution fraction, that means we take this and plug it into the other equation. So that means wherever I see an x in this top equation, I am going to plug in a negative y plus 200,000. So I have 0.08 times negative y plus 200,000 plus 0.03y equals to 13,600. These one too many zeros. Okay, so now we need to just simplify. So this will give me a negative 0.08y plus, let's see what that happens to be, 200,000. Do I got enough zeros? 200,000 times 0.08 will now give me 16,000. So 16,000 equals, oops, not equals, what do we forget? 16,000 plus 0.03y equals to 13,600. So then my next step is to finish and combine my like terms on one side. So this will give me a negative 0.05y if I combine this term and this term together, plus 16,000 equals to 13,600. So I would now need to subtract the 16,000 from both sides. And then this will give me a negative 0.05y equals to 3,600. but I'm just going to make sure since I'm doing it backwards. 16,000 minus 13,600. Oh, 2,400. All right. So that'll give me a negative 2,400. All right. Divide both sides by a negative 0.05. 0.05. And we take that and divide it by the 0.05. It's going to all equal out to be something positive, and that gives me 48,000. So my Y value is $48,000. Okay. Now, once you have solved for this, remember you need to go back and plug this into the original. An original means something that we did not change, okay? Meaning we did not manipulate by multiplying or dividing or anything like that. So in this case, I can plug it back into this one right here. So this will give me X equals to negative 48,000 plus 200,000. So all we need to do now is subtract 48,000 from 200,000. Miss Parker's just doing it bad on the calculator. But I will know that my Y would equal to 152,000, if that's correct. So, oh, not my Y, my X. So the X amount of values, if she's putting in that 8%, is going to be the 152,000, and for the Y is going to be 48,000. All right. Now, if we move on to a couple of other different things that's in the chapter will talk about break even. So if a company is said to break even, that means is when the total revenue equals to the total cost. That means that our R function, our revenue function, equals to our cost function, right? And if we wanted to know anything about a profit function, we would say that that would be the revenue minus the cost function. All right. So these ideas are really important when we want to deal with statements that talk about break even. All right. So it says, suppose a company has a total revenue for a product given by R equals to 5,585x, and its total cost is given by C equals to 61,740 plus 440x, where X is the number of thousands of tons of product that are produced and sold per year. The company is said to break even when the total revenue equals to the cost. That is R equals to C. It says find the number of thousands of tons of products that gives break even and how much the revenue and costs are at that level of production. So this is simple. We have been given our cost function and we have been given our revenue function. So because we've been given these two functions and we want to figure out that thousands of tons of product at the break-even point, we set our two equations equal to each other because I just said break-even means that we want to do the revenue function equal to the cost function. So this will give us 5585x equals to 61,740 plus 440x. Now we want to find our x value because that's what we want to know, the tons of product. So we would subtract the 440x from both sides. All right. And then we would say 5,585 minus that will give me, what is this going to give us? That'll give us a 5, right? A 4, a 1, and a 5. Okay. I'm just going to double check my math just in case Ms. Parker is really having a long day here. So 5585 minus 440. Yeah, okay. And I just forgot my x. Equals to 61740. So now to solve for it, we only need to divide by 5145. Divide both sides by 5145. And so x will equal to, when I plug it in, 61740 divided by 5145 gives me 12. So that means 12 tons of fun is when it breaks even. Okay, that's how much tons of products. 12 tons. Okay, so the next part of the question asks us how much revenue and costs are at the production level. So that means if I'm looking for that revenue, that R of X, I'm just going to plug in my value for X. So that'd be 5585 times 12. So we take 5585 times 12, and that equals to 67,000, and I believe it said $20. Yes. So my only last little piece that I need to do with that is it asks for how much is the cost. The cost should be relatively the same exact thing. So if I put in for my C of X, 61,740, because it's the break-even point, we should get the exact same number for our revenue function. So if we test our theory, 6170740 plus 440 times 12 will now give us the same amount, 67,020. And again, it should happen that way because it should be our break-even point. So that means they should have the same exact number. Okay, now if we talk about a market equilibrium, that means that the demand of a product that is demanded by consumers, that's what your demand is. The supply is the quantity that is supplied. The surplus, always surplus means you have more. So that's if the price results in more units being supplied than demanded. And the shortfall is if the fewer units are being supplied than demanded. And then the market equilibrium is the supply quantity that equals to the demand quantity. That means that we're at the neutral ground.